Hello everybody. In this lesson, I will teach you how we can write a Python code for Siena architecture. And for this lesson, we will use PyTorch. And let's begin. Look at here, import torch.nn. What's that? This imports PyTorch torch NN module, which provides classes and methods for defining and building neural networks. And specifically, this NN module, this is the base class for all neural networks in PyTorch. And class CNN NN module, what's that? This defines a new class CNN that inherits from NN.module. By doing this, the CNN class can use all the features and functionality of PyTorch NN module. And init, what is that? The init method initializes the components of the network and super CNN self. And what is that? This line I'm talking. This calls the parent class NN module constructor, ensuring proper initialization, and self convolutional layers and sequential, and to max pool 2 dimension. What happens in this block? First, NN 2 dimension here. I mean NN convolutional 2 dimension. What happens here? It performs a 2-dimensional convolutional operation extracting features from the input image. In channels 3, the input has 3 channels and output channels 16 produces 16 feature maps. Kernel size 3. The filter size is 3 by 3 and stride 1. The filter moves 1 pixel at a time and padding 1 adds 1 pixel border around the input to preserve its spatial dimensions. And NN value, what's that? It applies the rectified linear unit activation function. It introduces non-linearity, setting negative values to 0. And here, NN max pool 2-dimensional. What's that? It performs max pooling, reducing the spatial dimensions of the feature maps, and kernel size 2. What's that? The pooling window is 2 by 2. And stride 2. The pooling window moves 2 pixels at a time, halving the spatial size, and similar to the first layer, but takes here 16 input channels and produces 32 feature maps. Okay. And what are they? Self FC layers and other lines. What happens here? First, NN flatten. It converts the multi-dimensional feature maps into a one-dimensional vector for the fully connected layers. And NN linear performs a linear transformation. And first layer, maps the input vector of size 32 multiplied 8 multiplied 8 to 128 neurons. And second layer maps 128 neurons to 10 output neurons. Okay, and value adds non-linearity to the dense layer. And the forward function, what is that? The forward method defines how the input data flows through the network, and self-convolutional layers here, it passes the input X through the convolution layers, and self-FC layers passes the output of the convolution layers through the fully connected layers, and return X returns the final output typically logits, raw predictions before applying a softmax functions. And here, we have two convolution layers and the extra hierarchical features from the input image. And polling layers, we have it reduce the spatial size, making computation more efficient and introducing some translational invariance. And we have fully connected layers, combine the features into predictions for the final classes. And you will have input here, and here we have output, input 3-channel image, and output is a vector of size 10. Okay, that's all for Python and PyTorch for CNN architecture. Thank you for listening.